Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to talk about matrices. This is actually part 2 of a series I've been doing that goes all over different operations that we can do with a matrix. In this video I'm going to talk specifically about how to multiply matrices. In order to multiply matrices, we need to look at the dimensions of a matrix. So I want to go over how do you find the dimensions of any type of matrix. The dimensions are always going to be the number of rows by the number of columns that a matrix has. For example, if you had capital A, which would be talking about a matrix, and it has 2 by 3, that means that this matrix has 2 rows and 3 columns. An example would be if they gave you this matrix B, you can see that it has 1, -2, and 0 as its elements. If we look at this, this would only have 3 rows and 1 column. So the dimensions would be 3 by 1. When you're multiplying matrices, in order to multiply any two matrices together, the number of columns in the first matrix needs to be equal to the number of rows in the second matrix. That's kind of the first thing that we need to check in order to see if we can actually multiply them. If those two numbers match, then the product of the two matrices, so after we've multiplied them, then the new dimensions or the new order is going to be the number of rows from the first matrix by the number of columns in the second matrix. For example, if you know that your dimensions of your two matrices are 2 by 7 and 7 by 5, you need to make sure that those two numbers closest together, so the 7 and the 7, you need to make sure that those two numbers are exactly the same. Because this one both has 7s, that takes care of that first rule I talked about, that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So the new dimensions after I've multiplied can be found by looking still at the dimensions here. You take the 2 from the first matrix and the 5 from the second matrix, the number of rows from the first and the number of columns from the second, and that's going to be the dimensions of your new matrix. So the new dimensions would be 2 by 5. Again, to sum that up, the middle numbers, the 7 and 7, need to be the same number in order for you to grab the first and the very last number for your new dimensions. Let's practice just finding the dimensions if we were going to be multiplying matrices. If I have a 2 by 3 matrix times a 3 by 4 matrix, note that the 3's on the inner numbers there are the same, so my dimensions would be 2 by 4. If I try to take a 3 by 4 matrix times a 3 by 6 matrix, notice how the inner numbers 4 and 3 do not match, so we would not be able to do this. For this last one is kind of an extreme, but it's just showing that those middle numbers need to match. We have 8 by 100 and 100 by 2. So if those hundreds are the same number, which in this case they are, your new dimensions are going to be 8 by 2. So let's get into the process of actually multiplying matrices, because unfortunately multiplying matrices is not as simple as adding or subtracting matrices was, which was covered in part 1 of this series. In order to multiply any two matrices, there is a specific pattern that we need to follow. I'm going to show you a very general example using 2 by 2 matrices here, and I've labeled all of the elements with letters just to kind of keep it very general so that you could use this pattern for any type of matrices. Just know that if you have bigger matrices, the letters would continue to just expand those, so you could always create a bigger matrix and just continue to add letters to represent the elements. This outlines the pattern here, and I'm just going to talk through kind of what exactly you're doing. When you multiply matrices, from the first matrix you want to look at the first row, and you want to multiply those elements by the elements in the first column from the second matrix. So you can see how I have A times E, and then B times G. Now because you're doing two separate sets of multiplication here, you're actually going to add those products together to get your final answer. So after you've done your multiplication, you'll add your two numbers to get a single element. So when you get your new matrix at the very end, all of the elements should look like the old matrix did. You just may not have the exact same dimensions. Now because this example here has 2 by 2 matrices for both of them, the end result would also be a 2 by 2 matrix, but remember that can change depending on what your dimensions are. So I continue to show you that the second element kind of in that top row that you see there, I'm still working with the first row from the first matrix, but then I've moved on to the second column on the second matrix. So I'm taking A times F and then B times H. Now once you've taken that first row from your first matrix times all of the columns from the second matrix, then you need to move on to the second row. So I move on to CD for the bottom row of my new matrix there. So then I take that second row and I follow the same pattern where I have to multiply it by all the columns in the second matrix. So I'm taking C times E and D times G and I add those together. Then I take C times F and D times H and I add those together. So you'll notice in my typed out form here of the pattern that the second element in all of the parentheses sets stays the same. The only thing that is changing is my A and my C and my D and my B. So E's line up, G's line up, F lines up, and H's line up. That is a pattern that you'll always see when you multiply. So the first number is the one that's changing because we're switching between the rows there. The columns are going to stay in the same order because you're just going through each column one at a time. So let's look at a specific example. And again, I'm going to show you some examples using the 2 by 2 matrices here. Again, we could get into bigger matrices and you would still just follow the same pattern. For this example, for this first one, I have 2, 3, negative 1, 0 for the first matrix, and I'm multiplying that by 4, negative 5, 3, 1 in the second matrix. I have it all typed out here, and I'm just going to talk through, again, that pattern that I followed. So I'm taking that first row, 2, 3, times the first column, 4, 3. So 2 times 4, and 3 times 3. Then I move on to the second column, so 2 times negative 5, 3 times 1. For the bottom row of my new matrix, I take the second row times the columns. So negative 1 times 4, 0 times 3. Negative 1 times negative 5, and 0 times 1. Now after I've set it up with all my multiplying, what I do before I add is simplify a little bit by multiplying the numbers that you see. So I'm taking 2 times 4 and 3 times 3, and that's why I wrote 8 plus 9. So I continue to do that for the rest of the three elements there, and I have negative 10 plus 3, negative 4 plus 0, and 5 plus 0. So then I add, so I have 17, negative 7, negative 4, and 5. So because I dealt with a 2 by 2 matrix for both of them up there with the multiplying, the end dimensions are also going to be 2 by 2. So this end matrix looks like those first matrices do, but that's just because the dimensions are 2 by 2. So I have another 2 by 2 matrix here, and I've worked through the pattern again. So 3 times 1, negative 3 times negative 1. That's the first column, the first row times the first column. And then I move on to the first row times the second column. 3 times 2, negative 3 times 4. Now that I've taken care of all the columns, I drop down to the second row, 2, 0, and I multiply that times the columns in the second matrix. So 2 times 1, 0 times negative 1. 2 times 2, 0 times 4. Multiplying those numbers, I have 3 plus 3, 6 plus a negative 12, 2 plus 0, and 4 plus 0. So my end result is 6, negative 6, 2, and 4. For this next one, I have different matrices than what I have shown you. And the first thing that I would want to do is check the dimensions of the two matrices. So the first one is a 2 by 3 matrix, and the second one is a 2 by 2 matrix. This would not be possible to do because, again, if I look at those dimensions I said to you, 2 by 3 and 2 by 2, those inner numbers don't match. I have a 3 and I have a 2 from the second one, so I'm not able to multiply these. If you're ready to give it a try, I've created a practice quiz on a website called quiziz.com, and it is a multiple choice platform where you can go and practice the skill that you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.